Hey guys, it's Emil here. In the last video, we went over the calculation of the the uranium F orbitals, the Hubbard U correction for that. Um, so now we have both of our atomic corrections done. Now we're going to start off with our uh, standard collinear calculation. The collinear calculation, nobody really refers to it as a collinear calculation, firstly because that's sort of the standard here. Um, But for the naming conventions, just know that this is, collinear, standard, it's the normal one. Uh, Regular DFT+U. So now I'm going to change directory. I'm going to make a new one. I'm going to call it, I guess, Collinear. And now I'm going to copy over the Pascar. Ooh. What? Oh, ground. I'm going to copy over the K points. I'm going to copy over. Ooh, actually, not the pot car. The N car? No, we're not. Okay, the in car is. We don't really need that. But we do need to remember that N bands is set to 90. So I'm going to copy this, I think. What else? Let's take a look at the in car. So let's comment out the density of states portion. All right. Now, standard optimization as usual, right? N core is 6, L wave true, we're going to write the wave car. The structure optimization portion is going to be uncommented. And let's see what our numbers were for the corrections. So we have, for uranium, 3.23. So let's adjust this. 3.26. And for our rhodium atom, it will be 3.13. So we'll check which one rhodium is. Also, let's adjust the pot car here, or excuse me, the Pascar. Rhodium is a final atom. So the final correction will be applied to here, 3.13. And we'll just, I think we'll do something arbitrary, like 0.45. I think I did in the previous one. And now LDAUL tells you which orbital it's going to be applied to. So S is 0, P is 1, D is 2. And 3 is obviously going to be F. And LMAXMIX is going to be 6 for F electrons, which is, what we have here. And that should be all good to go. So again, this portion comes in during the non-collinear portion. Let's take a look at our Pascar again. That looks good. Let's take a look at, actually we need to do the pot car. The potentials. Uranium, germanium, rhodium. So pot create uranium, germanium, and rhodium. And then our K points are still set from before. think that should be it. I'm going to put K port 2. And then let's double check the job. That's going to be 36. Let's change the title here so it's Collinear first optimization. And let's run it. And we will see how it goes. So as you can see here, we've pretty much completely optimized the system. I did rerun this by copying concar to poscar and running sbatch job again. I've done that a total of 3 times. Anything over tends to be pretty excessive. And of course you could check the status of your energy as so. And you can see in this 3rd iteration it is pretty much not converging much. So we've met our convergence criteria, and that's pretty much it for the optimization. So again, when you see this, that's when you're going to copy it over. You know, this optimization iteration is done. Copy concar poscar, and you could tail F out as I did before, and then also this to view the total energy of your system. In the next video, I'll be going into the electronic structure of the collinear calculation. So again, thanks for watching. Any comments down below, and we will be moving forward with our uranium, rhodium, germanium system.